Welcome to my DIY motor controller head design. In this project, I have used 2 times TB6612 FNG motor controller in conjunction with the PAF board to create a functional Raspberry Pi head. Now, let's get familiarized with the part. Now, as you can see, I have used a simple PAF board and two TB6612 FNG motor controller in series. In this way, the common connection, I just let it go through. As you can see the strip of the path board. But that one I have to disconnect. I have just used a sharp object to wire off the connection in between. The result, you can see my Raspberry Pi 4 controlled omnidirectional car using the motor controller board. Now, for the further explanation, let's get to the bare bones circuit. Now let's discuss from the basic configuration of TB6612FNG. As you can see the pinout of the motor controller, I have used slightly different version, but nevertheless I will show you the full schematic. So my Omni wheel car, as it is operating, the motor controller circuit itself is fairly simple. I will discuss all the pinout and its configuration with Raspberry Pi 4. I have used Raspberry Pi 4, but you can use Raspberry Pi 5 as well. As you can see, the top one actually I have used, but the bottom one is more common. As you can see from the GPIO configuration, 4 GPIO has been used to control 2 motor at the left, then another 4 GPIO for 2 motor at the right. Now the motor are getting the power, operating power from the 9-volt battery. You can use other more powerful battery, but the TT motor only works with 6-volt and 12-volt battery. So you can use a buck converter if you want to utilize it as like a 6-volt power source. At the display, you can see I have also mentioned the Python code, a bit of the Python code with the pin configuration. So basically for left side motor, as you can see, GPIO 17 is assigned for the input 1, then input 2 is GPIO 22, and then the other motor, left motor B1, is pin number 23 and 24. Same goes for right hand side motor. INA2 is pin number 6, then INA1 is pin number 13, then the other one, INB1 equal pin number 19, INB2 pin number. Now for better explanation, I have opened my FreeSync circuit simulation. FreeSync is a very visualizing way of simulating circuit. It's very simple to use and I highly recommend. Now let's go back to the pinout. First I will zoom. So these are the pinout. As you can see, left side motor connected with Raspberry Pi 4. This 4 GPIO is more crucial for this 2 motor control. So what are the pinout? So the first pin on the left is basically powering the motor control board, and this one is the VCC. So VCC is connected with the 5-volt Raspberry Pi 4 power supply. Then this pin is for ground. Ground is connected. There is a common ground with Raspberry Pi 4 GPIO. I'm saying Raspberry Pi 4, but that doesn't mean that you can't use it with any of the Raspberry Pi. You can use it with Raspberry Pi 3 as well as Raspberry Pi 5. So these are the motor output. So basically the board output, which is feeding the power to the motor, A01. So from my code at the left, the part of the code on my left, as you can see, I have named them LINA1, which is basically this pin. And the other pin is A02 in my code, which is LINA2. L means left, IN input, A2. So these 2 pin correlates with these 2 pin code out. Same goes for these 2 pin and the common ground. Now right hand side, this is PWM. So there is only one common PWM I created from one pin from this Raspberry Pi 4. as you can see, this is GPIO 12. So from my code, I will discuss the code in next video, but for this just keep it in mind that GPIO 12 I have used to generate one common PWM, and that common PWM then shared with both the board. So as you can see, this common PWM is connected with this motor control board and this motor control board, and obviously both of them are TB6612FNG. Next pin is that input 2. So basically GPIO 22 is feeding all the way to this pin, and then this GPIO 17 is feeding this input, and this is for the standby voltage. So basically I have utilized this PWM signal. That PWM signal is putting both the board standby. Then the other input from the Raspberry Pi 4, which is connected to GPIO 23, and the next one is connected to the GPIO 18. Now if I just zoom out and go to the other side of the control, so as you can see, so it's easy to understand this bit because these are just motor signal going from the TB6612FNG to the motor, but the control signal is coming from the Raspberry Pi 4, and for this one GPIO 26 is used, and the next one GPIO 19 has been used. Same for this one. GPIO 13, and this one goes GPIO 06. So basically this part of the signal coming from the Raspberry Pi 4, this is just only telling the motor control board how much voltage should go to these 4 motors. But the power source is actually this 9-volt battery, which is in turn using a buck converter. The buck converter is converting 9 volt to 6 volt, then 6 volt is used to run these 4 motors. In my project I actually used NiMH more powerful battery. Those are like 36 volt battery, but I have used this same buck converter to reduce the voltage, to step down the voltage from 36 volt to 6 volt. Now another power source, 9 volt power source I have utilized in this project, that is to power the Raspberry Pi 4, because the whole circuit is used in a mobile robot platform, so the Raspberry Pi 4 requires its onboard power supply. The problem is that 3 amps, 5 volt 3 amps, the power requirement of Raspberry Pi 4 is too difficult to share one power source. That's why I have used completely a different power source only for the Raspberry Pi 4, and that is simple enough that you get a 9 volt power source or 34 volt, whatever, then you use a buck converter to generate 5 volt 3 amps. So basically this is the potentiometer. If you turn around at one point, you will get 5 volt, and you can use this one of these USB-C. This one is micro USB, but I have used USB-C. You can buy USB-C barebone connector just to connect this plus and minus output from the buck converter, then feed up with the Raspberry Pi 4 USB-C power source. That will power the Raspberry Pi 4. So this is what I've done here, as you can see. And I also put a buck converter so that I can use a separate power supply for the motor controller. At this stage, I have already soldered all the motors to the motor controller. As you can see, 4 cables from the 2 motor left and the 4 cables from the 2 motor right. So for now I have 2 of the buck converter. So one of them is connected with the motor controller board, and the other one's job is to power Raspberry Pi 4 in a mobile robot platform. I modified the end of the buck converter with the barrel connector. So these are 9-volt DC barrel connector. Same I did with the cable connecting from the battery. So this cable connecting from this battery, if I just connect it, as you can see, I'm getting 5.7 volt, which is kind of optimized for Raspberry Pi. On the other hand, the other battery, this battery, as you can see, this battery, the cable coming from there, if I just connect it there, so you can see I'm getting 7.3 volt, which is powering the motor controller board. Now I will power the Raspberry Pi. Hopefully nothing blows up. So as you can see, I'm having 5.7 volt here. If I just connect it with the Raspberry Pi, so you might be able to see the power LED is on. Now I turned on the mobile hotspot in my computer, and as you can see, the Raspberry Pi is detected and it is connected. I can access my little Raspberry Pi from my PC. So basically, I'm using my laptop hotspot to connect the Raspberry Pi. As you can see, the Wi-Fi is on, and the Wi-Fi hotspot, the onboard hotspot, is connected with the Raspberry Pi, and the VNC viewer is connected, is helping me to get connected. For the test platform, I'm using my portable power supply just to see the fast movement of all the wheels. Let's see if the robot works. So forward movement, reverse movement, left movement, right movement. Now is the time to do outdoor trial. So I'm taking it to my hallway, and as you can see, it is working. There is some discrepancies which I need to work on to improve. Mainly the wheels are a little bit loose. One of the wheel actually actually falling off, as you can see, and one of them is having difficulties in the traction, but nevertheless it is working, and these minor discrepancies I'm sure I can fix. Now the next part of the project is to improve and adding more functionality like sonar sensor and IR sensor kind of thingy. Be part of this channel, like, comment, subscribe and share. I will see you at next time. Thank you very much.